Dear students, in the previous lecture we had discussed about the different tillage equipment, particularly the moldable plow, disc plow, harrows and different types of harrows. These were all 3-point linkage mounted equipment. Now we will be talking of an equipment which is driven by the PTO of the tractor. You may recall I had told you that PTO is the one where maximum power is available out of the tractor, but it is least used. However, this is an equipment, there is an equipment now which is very much in use now and gives the and uses the power of PTO, and this is rotavator. Of late it has taken very much importance, particularly among the farmers, because of the simplicity and because of saving in time as compared to other equipment. We may know that when a field is to be prepared, the plows, the primary tillage, secondary tillage operations, several operations, and then planking has to be done before the seeding is done. Now, in this equipment, you do not need so many passes of those equipment, and hence we are saving energy. From that count, this equipment is very useful. So, we will have an idea about this equipment or other rotary tillers. So, I have named this lecture as Mechanics of Rotavator or Rotary Tillers. Now, in this we would like to know what are the details of a rotavator. Well, what a rotavator is? You might have seen in the field its operation in the second class itself, but let me give you some more details of this particular equipment. This is a equipment which is operated by PTO of the tractor, and it is an active tillage equipment. It is an active tillage equipment. It has certain basic components which are essential from the point of view of the designer or the user. You must have a look at it. First is the universal shaft. Why I say universal shaft initially? Because this is the shaft through which the power is taken from the PTO. Now, this has the components. For example, it has a universal hook joint. On this side there is another hook joint over here, and there is a cordon shaft in between. So, this total is the one from where we are taking power from the tractor and giving it to the rotavator. Now, in this rotor then we have a gearbox, here. Now, this gearbox, you can see that when the power from the PTO is coming, this power is rotating in one direction, and we would like to change the direction of rotation to 90 degrees, because then the rotavator, the axis of the rotavator is perpendicular to the direction of operation of the tractor. So, in order that we get this rotation, we have to have a gearbox which will change the direction of this, and here I will give you more details of this in the next slide. Now, there is another aspect which is the how the power from this gearbox is given to the shaft, to this shaft. Here is the chain or gear drive. We will show you this also, how it is connected, because once the power is taken from the gearbox to the shaft, there is a reduction in the speed, because the PTO returns at about 540 rpm, but the rpm of this is much lesser than that, about 210 to 20 to 30, in that range it varies, revolutions per minute. So, well, there is another important component of this rotavator is the board. Now, this board, you can have a look at this board, which we call as the trailing board. Now, this board has two main purposes. You know, when the equipment is operating, many a times there could be stones, etc., and if there are people around, maybe the person who is operating, and there could be another helper, etc. So, some of these stones, etc., may get thrown and hit the person, or even some other maybe dust, etc., which may come and disturb the persons around. So, for that, this cover helps us in covering that and gives a safety cover to that. Second usefulness of this is that it gives planking purpose. That means, you do not need to plank the field after rotavator has been operated. So, this is one of the very useful part of this particular equipment. Then the rotor and the blade assembly. So, you can see here that this is the rotor shaft here, and at that shaft there are several discs, single discs are there, and each one of these discs there are blades. We will talk of this slightly later, but then there are certain blades. Now, these blades help us in cutting those soil as well as stresses which are there when the equipment moves. So, this talks of the total, and this is connected to the 3-point hitch. It is connected to 3-point linkage, but the power is coming from the PTO only. For lifting and lowering only we are using the 3-point linkage. Let us go to the next slide. Yes, types of blades. Well, I have shown you the blades and how they are connected, how they are fixed into the shaft of the rotavator. Now, see the types of blades. There are 3 main types of blades which are used. The L type of blade. Now, this blade works very well for trashy conditions. This works very well for trashy conditions, although do not pulverize the soil very much. It does not pulverize, but then when your trusses etc. are there, I think this type of blade, L shaped blade, will cut it and then put those things on the field and virtually try to conserve the moisture of the field. The next one is the twisted blade or curved blade type, This is suitable for deep tillage, relatively clean ground, when the ground is clean, or maybe in the orchards or so. But it has a problem. Now, the problem is because of the short length of this, or you can say the short length of this particular blade, that the trusses etc. they get entangled or get wrapped into this the shaft itself. So, that way you can say that this will create a load onto the tractor. Although it must be told here that the rotavator is a negative draft implement, because when it rotates, in fact, the total draft which should have been there, that draft gets reduced by the amount of power that the rotating element takes. So, although that is there, but then it will help, it will not help if this particular blade is used, because it may have clogging and wrapping of these trusses onto the shafts. So, this is one of the, you can say, the problems with this, but then it has its own advantage which can be used in a orchard. Straight blade. Well, straight blade, these are employed on mulchers, as I said even while talking of the L type blades, because many a times when after the say wheat harvesting, when this equipment is operated, the stubbles are about 5 to 6 inches high, and then they need to be cut and then left in the field itself, so that they will conserve the moisture, and then you can have the operation, and you can have even seeding, because there are equipment available for say like 0-till drill. You can use this thing, and after that you can sow the equipment sow the seed immediately, because you will save moisture and also timeliness of operations. You will not lose more time in that, as well as the weather, which will help you in next crop. So, these are the 3 important blades which are used with the rotavator. Well, certain further information about the construction of the rotavator. Well, we have talked of all the components, how the components look like, where they are placed. Now, we will talk about these components slightly in detail, about their construction, about their material of construction, etc. For example, the blades. The rotor blades are made of high carbon steel or chilled cast iron, because we know that these blades are the most important component of the rotavator, because if these blades do not last more, then the farmer will have a lot of problem in each time changing these blades. So, the blades must be made of a good quality material, and the sharpness of the blade must be maintained for a longer duration of time to get more output. Shaft. the material of the shaft. These materials are normal carbon steel materials or its alloys are used for the shaft of this rotavator. Now, after these, then we have reduction units. I discussed in the previous slide itself the primary speed reduction unit. See, what happens is, we know that the PTO is operating at 540 rpm approximately, and the rotor is not operating at 540. So, how to reduce this? And for reduction of this, we have to have a two-stage reduction process. In the first stage, what we are doing is, we are in fact having the RPM approximately. Okay. Bevel gears are used. Now, what we do is, first stage is in the gear itself, which is there directly when we have connected the tractor PTO through the cardan shaft. You must have seen through the cardan shaft to the gearbox, and that gearbox, as you have seen in the previous slide, that gearbox is just on top of the whole equipment. So, there we have bevel gears, sometimes worm gears. You know that worm gears are also used for non-intersecting shafts and for giving 90-degree power transmission. So, you can use any one of these. So, these are used. So, there also we have a reduction by using this pair of the gears and change in the direction of rotation. So, this is one stage. The second speed reduction takes place because this you have seen that this particular shaft is connected to a gear mechanism. I had shown you in the earlier one, maybe in the next slide I will show you more details of that. But then there are chain and sprocket assembly. This will show you the chain and sprocket assembly here. See, chain and sprocket assembly. So, this chain and sprocket assembly, we know that chain and sprocket do not allow lot of loss of power, and that is why it is easier to use them rather than using gears or using belts. So, some rotavators may instead have 3-pair gear assembly for transmitting this drive also. So, you can have gears, you can have these. Now, depending upon the requirement, depending upon the type and depending upon the size of the rotavator which the manufacturer wants to make, I think he will have to decide on these. Then the trailing board, I told you about this trailing board, the usefulness of this trailing board I told you already. I must emphasize once more here that this unit is made of mild steel, and it helps in particular safety feature as a safety feature, and hence reduces the human drudgery. So, these are important points, and of course, it levels the ground or levels the field. Once it has been curved, it levels the field also. So, these are the different components and their construction, including material of that. I need not tell about the material of the gears, etc., it is well known. But then we have talked of the materials of the blades, materials of the shaft, then we have talked the material of the trailing board, which helps us in leveling the ground as well as a safety feature. Now, we will go to the next slide. Well, once you have seen that the equipment has a shaft, and then there are several blades, and then the power is coming from the PTO. Now, what happens to this particular power? How the power is being utilized in cutting the soil, particularly when we want the manipulation of the soil for preparing a seed bed. So, it is very essential to know the trajectory of these cutting elements. We call here the kinematics of working elements. The blades are the working elements here. What is the trajectory here? Now, you see that we have the rotor here, we have the rotor, and then the blades are onto that, the blades are on that. So, so now these blades when the rotation takes place, they will be moving forward, and once they move forward, they will definitely cut a certain section of the section of the soil. Then when it goes further, there will be another section cut. what happens is that there are two important things to be considered here. One is the speed of the tractor, and the second is the peripheral speed of the rotor shaft. There has to be a good relationship or a designed relationship between this speed of the tractor, forward speed of the tractor, which we designated say V, and the speed of the speed of the rotor shaft, the peripheral velocity of this. So, there has to be these important relationship. Now, when we talk of this relationship, then only we get what is the amount of soil which has been cut, or what is the amount of cut of the soil or the width of the soil that we have cut. How it cuts while in rotation? Let us have a look at it. See, when a rotary cutter with rigid teeth, or when the say any one of the blades which we have shown earlier, any one of the blades, what will happen is this is the center over here. So, from there when the element is having a horizontal axis of rotation, during horizontal axis of rotation, it is seen that when the blade moves at an angle alpha is this value at this particular point, where the value is say about 20 degrees. So, at this point you can see that at this point the cutting starts, and this ends somewhere, this goes and it ends somewhere when the angle is about 100 or so. Now, when the angle alpha reaches a value of about plus 100 at concurrent and about 340 lower at reverse revolution, it means the process of cutting soil slice comes to an end. That means, now concurrent, and this must be told to you. Now, see what concurrent means. Many times when we have the blades put in such a way that in the direction of movement of the tractor, the cutting is taking place. Many times in that case, of course, we do not get that much of pulverization, but when we reverse the blades and by changing the transmission which we had discussed earlier, the transmission as well as the orientation of the blades with respect to the discs which are there on the shafts. So, when you do that, you will find two types of operations. One is the uppercut, the upcut, the other is downcut. So, in case of the downcut, actually when we are talking in the forward direction, this is called as concurrent. That means, it is in the same direction. When the tractor is moving in the forward direction, the cutting is also taking place in the same direction. So, in that case, this cutting, the cutting width, actually the length of the soil slice starts here at alpha is equal to say 20 degrees and ends at plus 100 degree in case of a concurrent. Now, when this is there in case of a upcut situation where we have changed the direction using the same shaft, the same shaft, but change the direction. In that case, we find that the cutting starts at 260 degrees. So, 260 degrees here, somewhere here. So, this is alpha 0, it comes to 260 degrees. So, it starts here and then it ends up to this, that means 340. So, this comes somewhere about here, and then it ends. So, this soil slice is changing. Now, here only it is the mechanics of how the soil slices are cut in the two different situations of the motion of the blades, whether it is a upcut or a down cut in the case of the concurrent movement. That means, movement in the same direction, where u is in the same direction and v is also in the same direction. Then we have this thing. Well, this we have taken from a source over here to explain the details. You may have more details, you may see there itself. Now, so alpha 0 is the angle of rotation during the period measured from the axis x in conformity with the direction of rotation of the set. So, with this is what omega t gives us our alpha 0. Now, another situation where, now we talked of the blades where the axis was horizontal, where the shaft was horizontal. Now, there could be a situation where the shaft is not horizontal and is a vertical axis of rotation. Now, although these are not in vogue nowadays, but I thought worth having a look at this for your information, that if these are in a vertical axis, how the length of the soil slice changes, and if it is a rotary cultivator with spring tine, then how it will change. So, these three situations have been explained here. You can see that a rotor with vertical axis and a rotor cultivator with spring tine. We had talked of the horizontal axis in the previous slide. So, in case of this, you can just have a look at this, that same angle omega t which was there earlier. Now, the L starts here. The soil slice at an angle, the cutting operation of the soil slice at an angle of alpha amounting to about minus 100 degree, and the process comes to an end at the value alpha 0 about plus 100 degree. It is very simple, because then since it is in the vertical direction, it is easier to understand that where it starts and where it will end. So, it starts at about minus 100 degree and then closes at plus 100 degree, or even lower than that, depending upon the size of the blade that has been used over there. In case of C, the rotary cultivator with tine here, you can see that the length of the soil slice is so small. This is so small here, although this is a very good amount of soil slice which has been cut even in the vertical axis. But in the rotary cultivator with tines, with spring type of tines here, this is the slice, the width of the slice, or you can say the length of the slice is very much low, and I would say that these would not be preferred very much for operations. You can also have a look at the total working width here. Total working width is this in case of a vertical one, this is the total working width, and radius of the working set, total radius of the working set is shown over here. Now, these are the details of the three types of the shafts connections with the blades. Now, let us go to the next portion as to what happens to these blades and how we use the these elements into design. Yes. Now, we just talked of the length of the soil slice. Now, how important is this length of soil slice? It is definitely important, because then we would know as to what is the total volume of soil which this rotavator is handling, because on that itself the power will depend, and we will have to have the power source accordingly designed. In my later course of this particular lecture, I will also let you know how to design the rotavator and what are the various other features which will come into play. The one which is coming to play at this point of time is the bite length here, or the length of the soil slice. Now, this it is very easy to understand once you are knowing about the rotation of the shaft and rotation of the blades. You can very easily compute what is the bite length here, or the telling pitch or the length of the soil slice, which we have shown earlier. Now, you can have a look at this, that if n is the number of revolutions of the working set over here, and if j is the number of working elements in a plane, then v being the velocity trouble speed in the forward direction, we can simply get L, which is the bite length given as this here. Or if we take care of the speed of the, if we can take care of the speed of rotation of this, that means speed of the peripheral speed of this, we will find that the relationship gets changed to a very regular one, where we get V and V by U. Now, this is very important factor here. R is the radius, and Z of course, I have said about the number of elements in one plane. Now, V by U, this is an important factor so far as L is concerned, as well as this also talks of the total volume of soil which has been handled. So, when V by U, you can have a look on this side. We have shown you the dependence of the shape of the soil slice on the direction of concurrent and reverse revolutions, very important on the rotary culter at various ratios of U and V. Now, you can see the length of the soil slice depends upon the speed ratio U by V here. Now, you can see here that as U by V is increasing, for example, U by V is 2.5, this is the cut here, this is what it is. When it goes to 5, you can see the amount it has come. When it comes to 10, it has come much less. When you go to the this is when the case is when the situation is reverse revolutions in the upcut type of rotavator blades when they are continuing. When you take care of the concurrent revolutions, then you have a look at this here. You see here that u by v when it is 2.5, see this is the amount which is cut. Now, u by v which is 5, this is the amount much compared to this. So, you can find that the concurrent one definitely gives a higher volume as compared to this. Even at value of u by v as 10, this is higher than this value of this value in case of reversed one. So, we can say that u by v is a very important factor to be considered when we are considering the design of the rotavator, or when we are considering finding out what should be the size of the blade and all other details of the design. Most rotary blades have 2 to 3 cuts per revolution. Yes, how many in a revolution, how many such cuts will appear? Now, these it has been found about 2 to 3 cuts will take place. So, depending upon the u by v ratio that you take, you will have these details known to you. Now, let us go to the second slide. Well, cutting speed. So, from there itself we can have an idea about what the cutting speed is. Now, this is the cutting speed which has a relationship with u, v and angle alpha. Now, this angle alpha is the angle of rotation of the rotavator discs. So, with these the cutting speed has been formulated to be u minus v sin alpha by this. Now, you can see that v is the speed of the rotor and v is the forward travel speed here. Increment in the cutting angle, and now delta you can see the delta is the increment in the cutting angle. So, with this you find that us is given by this here, and then us, if you for a ratio of u by v exceeding 5, we can adopt that cos delta is 1. You can say that the value of cos delta which is coming over here can be taken to be 1 for u by v is equal to 5. Now, there are you can have a look at this, because this angle alpha has a variation with respect to this delta. Now, when we want to consider this alpha, this delta, we need to look into this particular table. This data is already available, and once we have this chosen accordingly, we can look at the value of alpha and take this value, and from here we can find out the cutting speed of the forces of cutting. So, immediately then you can also know what is the cutting force on the blade, because then blade will have a certain torque, the radius of the set is known, because we know right from the center of this we can find out what is the total radius here. So, this radius you can find out, and m is the torque coming onto that. So, we need to find out the total torque. See, peripheral force constitutes these two things, one is Ks and the other dynamic force Kd. Well, arrangement of the working elements on rotary disc, how they are arranged, it is very important to know. Once you know the details, it is very important to understand as to how they are arranged. Now, these are arranged with respect to see the spacing A here, regular spacing A 360 by I into Z into E here, because number of working elements and number of working sets. So, once you know that, because 360 is the rotation of that, so we should be in a position to find out the value of A, which is the working element angular scale between the working elements. That means, angular positioning of these between these two. Well, a problem has been taken keeping in view all those details, and you will find that this problem is nothing but simply putting those values, and you will get the length of the bite length or length of the slice which has been cut. Another problem on the similar count with certain change values and certain other considerations has been given, where we have tried to find out what is the total number of discs on the shaft, and just by putting those values and taking care of the details which we have discussed earlier, you will be in a position to find out the number of discs on this. Thank you.